I'm saying it all right, Rebecca. So floor is all yours, and you can
Perfect.
start sharing the screen there.
Will do. Thank you, and thanks for that. Yeah, can you see my screen?
Yes, yes, perfect.
Brilliant.
And I just a reminder there. I just want to check if the audience can see the chat function there. Can someone just text there, just saying if it works fine? Because last time it was not working. So okay, looks like, oh, test. Okay, it's good. Okay, thanks. It's working. All good then. Yeah. All right. I'll mute myself here. So you are.
Perfect. Thanks, Sita. Thanks for the invitation and for taking the time to listen to my presentation. So it's great to be a part of this webinar series, especially since it's delivered by women working in the industry. So yeah, I'm Rebecca. Rebecca Cachia. I work with Codema. We're Dublin's energy agency. So just a bit about myself. So I'm originally from Malta. So I did my undergrad in Malta. So I've bachelor's honors in architecture and civil engineering from the University of Malta. So the course there is a bit different. So it's a 5-year course essentially, and it's the first few years are architecture, civil engineering, and planning, and then the final years you choose your the path that you prefer to study. So I chose civil engineering, so that's civil with structural engineering. And while doing the course, I realized that I'm more drawn towards climate action, energy. So, in fact, I had done my, it was a tough course. So I had a thesis, dissertation project. So it was, yeah, a bit of everything. So while I was doing that, I realized that I'm more drawn to energy and climate action. So I did my thesis on green roofs, dissertation on green office buildings. So it's really, I suppose, prepared me in a sense for the energy and climate industry. Then I moved to Ireland in 2014 and I did a master's degree in sustainable infrastructure with DIT, or rather TU Dublin now. And over the years, I did a few different courses. To be honest, I couldn't really remember them all because they're, yeah, smallish courses. But I had a look at my LinkedIn to see what I put up there. So yeah, these are some of them. So I did a few courses with the University of Bath, with TCD. And one of the more useful ones was a GIS course with TU Dublin as well. So I use that quite a bit in my role, and I've used it to upskill some of my colleagues as well because we do quite a bit of GIS in Codema when we're showing some of the maps that we do for the, I suppose, for energy planning. So I continuously upskill in energy planning, energy and emissions modeling, the built environment, and climate action within that. I've done a few leadership and management training programs, project management training as well. So my career, I suppose, I started working in Malta in architecture and civil engineering there. So I worked with a few different firms, starting off as graduate and then working more in civil engineering. Then when I moved to Ireland, it was a strange time. So I moved in 2014 and Ireland had just come out of recession. So it was difficult enough to find a job then. So I started working as an AutoCAD technician with Wilson Controls. Essentially, they're an electrical engineering company. I was doing all their plans for them. They had won a contract at the time for Bank of Ireland. So we were doing all the electrical plans for Bank of Ireland. Um, then I started working as a structural and civil engineer with David Meyer and Associates. So it was more on the structural engineering, I suppose, type of work. And it was good to see the differences between the work here and the work in Malta. So I suppose in Malta we would do a bit of everything. So you start with the architectural drawings, the seeking for planning permissions, looking at the civil and structural plans as well. So here it was a bit different in a sense that the roles are so separate. So architectural firms would be sending over their drawings to the structural and civil engineering firms. So it felt like a lot of back and forth trying to get information from one team to another. But also it seemed good that each team was focused on what they're doing. So yeah, it was good to get an idea and a sense of how things work here. Um, then I started working with Codema. So I've been working with Codema for 7 years. So I started there as an energy analyst, an energy engineer, and now my role is as senior engineer and I lead on energy planning and emissions modeling. So I've worked on a number of different projects with Codema. It's um, a great team that we have there. It's a lovely working environment. Um, so it's been good to be working there for a number of years, I suppose. So I've worked on different EU and local projects. I've focused mainly on energy planning, building efficiency and emissions modeling. So in energy planning, one of the major projects that I've worked on was the Dublin Region Energy Master Plan. I've helped write a number of energy and carbon assessments to inform city and county development plans. Also helped develop the decarbonizing zones evidence base, um, worked on projects, mainly projects on emission quantification. So specifically quantifying emissions from spatial planning policies, and creating spatial energy mapping tools. I've also helped to create the climate change action plans in 2019 to 2024 for the Dublin local authorities. So these climate change action plans then were replicated, I suppose, throughout Ireland for the other local authorities. And they've since been then updated to 2024. So the local authorities have revised these and used a similar approach to the 2024 climate change action plans. So within these, I helped develop the energy and emission baselines assessments, adaptation baselines, risk assessment for different sectors in the Dublin urban environment. So yeah, it's been a lot has been going on in Codema, I suppose, and over the last 7 years, I've been working with them. While doing that, I also worked as an assistant lecturer in TU Dublin. So I was lecturing on AutoCAD. So I was doing that part-time, and it was two part-time civil engineers in the TU Dublin Bolton campus. So it was quite daunting having to teach students, and especially so because most of them were older than I am. They were all part-timers, so they were all coming either from the industry. So some of them were builders, some of them were CAD technicians that wanted to change their career and move into civil engineering, but was yeah, I suppose it was a very enriching experience. So it was a good, a brilliant experience. So Codema and the work we're doing there. So Codema is Dublin's energy agency. We're a not-for-profit public good company limited by guarantee. We work on behalf of 4 Dublin local authorities. We're really their energy and climate advisors. So our mission is to accelerate Dublin's low carbon transition, and we do that through innovative local level energy and climate change research. We also work in planning, energy planning, engagement, and project delivery. So the main objective of our work is really to mitigate the effects of climate change and improve the lives of citizens. So the work we do, I suppose, is mainly related to energy, climate action, and supporting global to local climate policy, looking at the policy from an EU level coming all the way to a local level, and addressing the challenges that come with those, I suppose, with those policies and different legislations. So looking at the different policy, I suppose, from a regional perspective, there's the Regional Spatial and Economic Strategy from the Eastern Midlands Regional Assembly. There's the National Planning Framework, Climate Amendment Bills, the Climate Change Action Plans, National Climate Plans, and all these policies, legislations, they all highlight the need for evidence-based data, energy, and emissions to decarbonize the region. So when I say decarbonize, I mean looking at ways to reduce our emissions to meet 2030 and 2050 targets. Excuse me. Sorry. So the main thing that we're looking at really is how can we act at a local level to help national and global climate change goals. So looking at a bottom-up approach to tackling climate action and reducing the emissions that we need to meet our targets. And the area I work in is energy planning. So what's energy planning and what is the role for energy planning? So essentially energy planning is evidence-based forward planning. So the essentially it's what we need to ensure that we have the required heat, transport, electricity infrastructure to serve both the current demand, the existing developments and new developments. And we do that looking at low carbon and low cost energy. So really linking and integrating spatial and energy planning at a local level. And this helps us to get a better understanding of energy use within our area. And it helps us to create local level evidence-based energy policy to help us better target areas for energy actions. So from this, then we can create baseline emission inventories, energy master plans, energy assessment, feasibility studies. So with energy planning, it really helps us to understand the challenges and the barriers. Where do we start? How do we tackle the need to reduce emissions, say, for example, in the residential sector? Where do we start? How do we identify emission reduction potential? What are the impacts, the social and economic impacts? So the likes of air pollution, poor residential energy ratings, looking at energy poor areas. So when we talk about energy poor areas, it's these areas where households would have to, say, forgo turning on their heating so that they can, because their electricity or energy bills are so high. So they'd use that money for something else. So it's really these areas that we need to try to tackle first. But how do we do that? What are our pathways to decarbonize the region to 2030 and 2050? What are policy recommendations that we can make from the evidence base? So an example of this, an example of a project that we've worked on in 2021 is the Dublin Regional Energy Master Plan. So we've used a lot of geospatial data, a lot of information to help us create the master plan. So this is the first of its kind in Ireland, and it builds on best international practice and is used as an example for other regions in Ireland to follow. So it's really a holistic, integrated energy model, and it looks at all the different energy sectors, so heat, transport, and electricity, and considers local technical constraints. It's spatially led, a spatially led twin of the local energy landscape. So this means that it looks at energy use in a geographical and localized way, looking at a neighborhood or community level across multiple energy sectors. So really understanding what's happening, where are the emissions arising, how can we reduce these in these specific areas. And the key outcome of this project is that it acts as the evidence base, I suppose. It considers the wider socio and economic impacts, so it's the likes of employment, health, fuel poverty, affordability. And it's as I said, the evidence-based to support climate action, related policy making, infrastructure planning, community engagement for Dublin's energy use. So it's really understanding, I suppose, in terms of energy planning and the geospatial data that we use is that it helps us to understand where are we now, what, where are emissions rising, what do we need to do to reach our targets, understanding the key sectors where these energy demands are, and what are the pathways to meet 2030 and 2050 targets. So really it's helping us identify emission reduction potential. How can we reduce emissions? Where can we reduce them? So with evidence-based planning, this can help us identify areas with the potential to increase renewable energy, reduce emissions. So this can be in the form of say specific areas that can take or specific buildings that can take building integrated solar PV, for example. But it's not all buildings that would be best located, would have the best location to take the solar PV. So then we might be looking at offshore wind, onshore wind, which are the best areas to locate these. Looking at areas that are, I suppose, more suitable for heat pumps or district heating. Where should EV charging, electric vehicle charging infrastructure go? So it's all this information, all this evidence base that helps us make, I suppose, uh, these evidence-based policy recommendations and recommend where action should be taken. And it's only because we understand and we have the information at a well, I suppose it's all spatially mapped out. So that's how then we can say this is where this low carbon technology should go, or where we should look at reducing emissions. So from the same example from the Dublin Region Energy Master Plan, essentially we're looking at identifying ways to reduce emissions and the pathway to 2030 and 2050. So what is our target? How much do we need to reduce emissions by, and how can we fill that gap? What are the different low carbon technologies that we can fill that gap with? How can we increase renewable energy? So it's really understanding, how to fill that gap, I suppose, between the targets and where we're at the moment. So just to give a bit of context, I know it's a lot of bars and a lot of figures on that chart. But what it essentially says, it's showing our historical emissions, the bars in blue. The green bar shows where we're at the moment in 2021. The red dotted line shows a business as usual scenario of emissions, how they'd increase over time, especially considering the effects of increases in population. So that would mean increases in developments, housing, a higher energy demand then. And then the bars between 2030 and 2050, they show the potential to reduce emissions and what are the different technologies there. So some findings, for example, are for the transport emissions. So this is all coming from that spatial data that we have all mapped out, the energy and emissions. So that has helped us to identify these key areas that we should focus on. So for transport, for example, we need to prioritize a shift to active travel, public transport. There's a high potential of offshore wind in the Dublin region. The same goes for utility scale solar PV. So that's the likes of PV farms, photovoltaic farms. And for heating, for example, we can see that there's a good opportunity for district heating there. So really what all this boils down to is looking at longer term goals. So informing energy, climate, and planning policies. So we need that evidence-based energy planning to inform policy and legislation, the robust basis to inform the energy policies, objectives, and actions for local, regional, and national plans and strategies, and identifying the synergies and overlaps in energies and climate action and policy as well. So that is why it's so important um, to have the evidence base where you can see that synergy, where the overlap is. It's useless if we're all working in silos and we're all off working on our own thing, if we don't see the overlap and how the work that we're doing, I suppose, maybe in energy, in planning, how that overlaps. So the main focus of this, I suppose, is really we need to have that evidence base, that understanding of what's happening, what is the potential to meet our targets. So that's the master plan, the evidence based, the energy planning, energy master planning part. But then we need to look at how do we meet these goals? How do we do this? So really needing that stakeholder and citizen buy-in and making sure we have that engagement piece going. So we can't be off to the side working on our own, looking at what's possible without then engaging with citizens and ensuring that they understand what needs to be done in their area, how they can look at how they can apply for grants, what are the different opportunities, I suppose. So it needs to be it needs to be well rounded, I suppose, that we're all working together towards the same objective. And I suppose the final piece then is implementation of projects at scale. So looking to deliver large scale investments that's required, I suppose, for us to meet these goals. That's it really from myself. If you have any questions, please go ahead. Yeah, I think you can leave the questions in the chat there.
Yeah, definitely. One has a question there. And you had provided the email there, right, Rebecca? So if anyone has, additional follow-ups.
Yes, yeah, please feel free to email me. It's at the end of my slides.
Yeah. Okay, so one question there. Do you know Earth observation technology such as, the satellite image, we call them sentinel. So it's not, anyway, just the, send like satellite images, have they been kind of considered for decision making, or is it not included at all?
Yeah, we
So that's
have
from
used.
Sandra Malloy. Yeah.
Thanks for that question. Yeah, we have used satellite imagery. The only thing is that because we work at, rather the data that we try to gather is at a local level, sometimes we find that the data from satellite imagery mightn't be as granular as we'd need it. But we do use that information to cross-check some of our work as well, just to make sure that say if we're looking at pollution or emissions, we cross-check that with satellite imagery to see that the areas that we're saying that are have high emissions, that they're the same areas. But our data then would look at more granular information, I suppose.
All right, thank you so much. And good to hear that like it's being used on the, on the bigger scale there. Another question there from Asling. Have you seen any on the ground results from your team's work so far around Dublin? So just has it been concrete, like, concrete result on the ground?
Yes, so I suppose we use the example I gave is the Dublin Region Energy Master Plan. We use that to inform a lot of the work we're doing. So I suppose in a sense it has already supported county and city and county development plans. There are policies in there and objectives within each development plan that support the master plan. So the findings from that have already been transposed into planning requirements for each local authority. We've also used the information to support decarbonizing zones. So each local authority in Ireland has been tasked to select a zone within its local authority area. And this zone will look at reducing emissions by 51% to 2030. And that information from the master plan has supported and is the evidence base for this decarbonizing zone. So we're currently looking at a number of EU projects to support, I suppose, the emission reductions that are needed. So looking at supporting the low carbon technologies that can be placed into these decarbonizing zone. So there's quite a bit going on in the space.
Yeah. Thank you, Rebecca. There's another question actually from Orla. What method was used to determine the suitability of Dublin Mountains as a site? What makes them optimal?
I believe that's for the wind farms that we were looking at. So there's a lot that needs to go. I suppose when we looked at this is all from a data point of view. Then it's up to the local authority then to see whether a wind farm is best suited in this location. So it's more like a pre-feasibility, and then we have to look at the feasibility study. But in speaking with the local authorities, I suppose with the mountains, there's for wind generation it's great, but then there are issues like visual impact assessments that need to be carried out. So there's a lot that needs to go into that before, I suppose, transposing the information there and saying, this project will go ahead. So it's the information, that's the evidence, and then it's passed over to the authorities to see which areas would be more viable, I suppose, for these low carbon technologies.
Right. Yeah. Thanks for that answer. I have one question. I don't want to take away a lot of time. I was just curious, actually, with the turning of like illegal, like pit harvesting is illegal. So is that now, like, how is that being addressed in the
Apologies.
yeah.
Bit harvesting.
No,
Sorry.
sorry, Sorry, Pete.
Oh,
Yeah, yeah. So does it now? What changes were necessary in the policy? I mean,
yeah, so we haven't captured that in the Dublin Region Energy Master Plan per se, but I suppose the idea is to look at alternative fuels to to phase out the peat completely. Then, so ideally, looking at different ways. Ideally, it's taken up by renewable energy, low carbon technology for heating. So there's different ways, I suppose, to support that policy of phasing out of peat. I hope that answers your question.
No, definitely no. I was just curious. I don't even know how much peat is there in Dublin, so but yeah, I was not 100% sure. So anyway, thank you so much for very insightful presentation, and people had a lot of questions, and of course they can follow you on probably on the social media, which means LinkedIn. So we have and also just a reminder, we'll have the presentation made available on the YouTube, so people can, if they want to go on detail, they can watch it there. So thank you so much, Rebecca. Yeah, so with that, we will move on to our second presenter. So we have our second presenter, Fiona Cawkwell from UCC, but she just notified actually she wouldn't be here. So, but she gladly sent her presentation, so which I'm gonna play right now. And then she also told us, like, if there are any questions, you can feel free to contact her on her email, which I will provide here on the chat there. So just bear with me while I share the screen, okay? And okay, share the screen.
Good afternoon. My name is Fiona Cawkwell, and I'm a lecturer at
Just checking there. Can anyone let me know everyone like the sound is coming right? I will replay that part.
University
Yes.
College Cork.
Yeah, okay.
I'm sorry
perfect,
I can't
perfect.
be with you this afternoon.
So,
I would love to be part of the group, but unfortunately I have another commitment on Wednesday lunchtimes. But what I'd like to do over the course of the next 20 minutes or so is take you on a short tour through the spatial, temporal and spectral resolution of my geoinformatics career to date. You might be wondering, what on earth does this mean? Well, when I start teaching remote sensing to my students, one of the first things I talk about are the 4 different resolutions of our sensors and our images: the spatial, the temporal, the spectral, and the radiometric resolution. The space, the time, and the spectrum of data. That's what I'm going to be talking about today. In terms of the spatial element, I want to give a little bit of the world tour that I've been on, starting in the UK in the 1990s with my education in remote sensing. And then a number of opportunities to do research in both the Northern Hemisphere, particularly up in the Arctic, but also in the Southern Hemisphere in Chile. And since 2006, I've been in Cork teaching at the university here. And you'll see that, as well as the coloured dots, the times and the dates that I've been in these different places, the colours vary because those colours are representing the spectrum of my activities. And when I introduce the idea of the electromagnetic spectrum, I often start with the visible part of the spectrum because it's what we're all most familiar with, the idea of colours. And we can see the rainbow of the visible spectrum on the screen there. And the colours of my dots there represent the different sections of the visible spectrum, or as I've thought about it, the learning, doing, guiding spectrum. The learning when I was in education myself, so the blues and the purples, the shortwave part of the visible spectrum. The doing of research in that green part of the spectrum, perhaps that most critical part of the spectrum, because that's where we get most of our energy from the sun. And in terms of my own career, a critical part of the spectrum because research has fueled all the other activities that I've been doing. And then finally, at the longer wavelengths in red, the guiding or the academic element, where I've been teaching, training, supervising, mentoring, and helping other people on their journey through their spectrum of remote sensing. So to go back to the beginning, I told my parents in the early 1990s that I wanted to do a geography degree. My parents, like many parents, said, well, what are you going to do with that? Are you going to become a geography teacher? I knew I didn't want to be a geography teacher, but I didn't know what I did want to be. And that's okay. And I say this to our students and particularly their parents when they come to open days or when they start at the university. It's okay to not know what you want to be because there might be something in your degree that really sparks your interest and your enthusiasm. And that's what happened for me. In the 3rd year of my BSc Geography degree at Edinburgh University, I took a module called Introduction to Remote Sensing. I'd never heard of remote sensing before. I didn't know what it was. But it really piqued my interest and I wanted to find out more. And I did that through a master's in remote sensing at University College London. And I had a year of finding out more of what is this remote sensing all about. And I enjoyed it so much, I decided I wanted to spend more time learning about remote sensing. And so I went to Bristol to do a PhD to find out more about what I could do with remote sensing and also where could I go with remote sensing. And the first answer was I went to Greenland because my PhD was looking at the contribution of cloud cover to the radiation budget of the Greenland ice sheet. This was at the end of the 1990s, early 2000s, when there was a lot of recognition of the importance of cloud cover within the wider climate change framework. But people were also very aware that we actually knew relatively little about cloud cover and an annual cloud climatology. How much cloud cover do we have over the course of a month, a season, a year? And how is that changing? We have a lot of good measurements from the surface about overall cloud coverage, but from the surface, we can only look at the bottom layer of clouds. Likewise, from the satellites, we can only look at the top layer of clouds. But at least by putting those two data sets together, we start to have more of an understanding, not just about the presence or absence of cloud cover, but whether we're talking about thick stratus, low-level cloud, or thin, high-level cirrus cloud, or something in between. So I spent a lot of my PhD looking at satellite images and trying to work out, am I looking at cloud? Am I looking at ice sheet? Because both are cold and white. But I used the thermal bands of a number of different sensors to try and distinguish not just the clouds from the snow and the ice, and as we can see in the graphic there, the melt ponds that form on the ice sheet when it's warm enough, but also looking at the heights of different clouds. I spent a lot of time looking at multi-angle imagery and using that and principles of parallax to calculate how high the clouds were above the surface. I was also very fortunate in that I got the opportunity to go to Greenland. We can see the red pin in the Greenland ice sheet in the map on the right-hand side of the screen there. And I spent 6 weeks on the Greenland ice sheet in 1999, helping a number of other colleagues with their PhD research and other funded research projects, but also making my own measurements about the weather, and in particular, the cloud cover from the ground. Not every day was a clear blue sky day, such as we can see in the image there. And then I finally wrote up that traditional book thesis that had 200 and something pages with lots of text and lots of pretty pictures, as we can see there, of cloud cover climatologies derived from different data sets. After my PhD, I wanted to carry on doing more research, and I had the opportunity to go to Canada, and I was based at the University of Alberta in Edmonton for a couple of years, from 2003 to 2005. And because my heart was in looking at the Arctic and the North and understanding more about how these very important polar latitudes were being affected by climate change, I worked for the Canadian contribution to the Global Land Ice Measurements from Space project. And this, as the name suggests, was a global project. There were regional managers in a number of different countries that had a cryospheric component, either glaciers or mountain glaciers or high latitude glaciers, such as in Canada. And we were tasked with the job of using satellite imagery to delineate where those glaciers were. And we were doing it repeatedly so that we could get some understanding of change over time. And so we can see there's one example of some of the locations of the Arctic glaciers and the contributions that we made to the understanding in the Queen Elizabeth Islands of where there was permanent snow and ice cover. Again, I was very fortunate to have the opportunity to go up to the Canadian Arctic. I went to Devon Island, which is the northerly of the 2 points that you can see in the pin there. Devon Island being an island about 2/3 the size of the island of Ireland. And there were 4 of us on that island doing research on an ice cap, studying a number of different elements of that ice cap. Again, I was making measurements that tied in very much with the research that I was doing, but I was also contributing to a number of other research projects. And both the trips to Greenland, but also the 2 trips that I did to Devon Island, really helped me to understand better what these remote northern locations are like. And I'd looked at thousands of satellite images probably by this stage of those areas. But on a satellite image, it's a very 2-dimensional blank feature. When you actually go to one of those glaciers, to one of those ice sheets, then you fully understand the 3 dimensions, the enormity of some of these features when you're actually standing there, and that feeling of, am I the first person to stand here and see this view? Perhaps not, but certainly I was the only person there at that time. But we were also doing lots of science. This is an example of one of the ground-penetrating radar devices that we towed behind a skidoo. We were trying to understand more about the shallow snow and ice underneath the surface in order to better understand how radar microwave instruments would interact with those surfaces. And ultimately, from the wider Global Land Ice Measurements from Space project came a book, multiple chapters, focusing on the different cryospheric regions around the world. And I contributed to a chapter on the Canadian Arctic glaciers, but also to some of the work that was being done in the Antarctic. And that came out of some time when I was in Chile in 2009, doing more research. In this case, it was part of my sabbatical, and I was based at two different research institutes within Chile there. Again, doing some field work, but looking at very, very different types of glaciers. These were mountain glaciers. These were much smaller ice caps, and also in stark contrast to both Greenland and the Arctic in Canada, very, very dirty glaciers. You can see there the surface of the ice entirely covered by wind-blown dust, by pollutants that had been created from industrial processes. But we can see as we drill down through the snow and ice, we've got layers which might be representative of particular meteorological events. But then we also have that cleaner white ice surface as well, reminiscent of a time when perhaps there wasn't so much pollutants within our atmosphere. Again, looking at the weather, we can only really understand some of the changes that our satellite images are showing us if we have these ground-based measurements as well. So we were setting up a weather station, and we were also visiting an active volcano, Volcan Villarrica, which has erupted on several occasions. And when it does erupt, of course, then there's potential disastrous consequences because of the thermal heating of all the snow and ice from beneath, the melting of that snow and ice, and then potentially catastrophic flooding. So that was all the doing of research that ultimately led me to Ireland in 2006, where I became a lecturer at University College Cork, and subsequently I've been promoted to senior lecturer and currently in the role of head of school. And when I was trying to think, what word describes what I do, I initially wrote the word teaching. I thought, well, actually, I don't do very much teaching, or at least I do a lot more than just teaching. So then I thought supervising, but again, I do a lot more than just supervising. I teach a lot of remote sensing modules, physical geography, research and quantitative methods. We have students across a number of different degree programs, geography, geoscience, environmental science, BSc and BA. And I wouldn't be doing my job properly if I didn't give a plug for the MSc in Geoinformatics that we have. If any of you have not done a degree, a master's qualification in GIS and remote sensing and are interested in perhaps following up on one, please do go to our website there. There we go, promotional moment over. But I also have a role in terms of winning funding for PhD students and early career researchers, and more recently, far more in terms of administration and resource management. And those resources are everything from the people who I work with, through to the data that we collect, through the different types of equipment and instrumentation that we use, as well as obviously, of course, financial resources. So as I say, we do work with a variety of different data types. My own work has very much been around the use of satellite imagery, particularly in the visible, the near-infrared, shortwave infrared and thermal infrared parts of the spectrum. But we also work with drone imagery. I have a postdoc and a PhD student who are using a lot of drone data as part of their research. We have a phenocam. Looks a bit like a CCTV camera, but it is actually a camera that is designed to take recordings of changes in phenology. And we have that installed on one of the university buildings here. One of the great opportunities that I've had throughout my career has been the ability to work with international colleagues. I've given examples of working in Canada and working in Chile, but even here in Ireland, I've had the opportunities to develop networks with people across the world. This is an example of one project where I was working with colleagues in Wales. It was a European funded project, an Ireland-Wales Interreg funded project, and we were looking at the Irish Sea, looking at both the east and west coasts of it, in other words, the Irish and the Welsh sides of the Irish Sea, and in particular looking at Greenland white-fronted geese and curlew, trying to understand more about their habitats. Where do they spend time? What do they do there? So I was working with colleagues who are ornithologists. This was the first time I'd ever worked with ornithologists, and I learned a lot about ringing and tagging of birds. We can see in the photograph there some examples of the geese that were being fitted with GPS tracking collars so that we could follow them over the course of the winter. We were particularly interested in where these birds were spending the winter season to understand more about their feeding habitats and what might be causing the decline of these species over those months. So they were fitted with GPS tags, But then we needed to know not just where are they, but what might they be doing at that location. And that's where the satellite imagery came to its fore, because we were able to produce very, very detailed land cover maps that helped us to understand, once we had the points of where the birds were, what kind of land cover were they on and what might they be doing there. Is this salt marsh where they might be feeding? Is this woodland where they might be roosting and sleeping? And I had a postdoctoral researcher, Dr. Walter Camaro, who was working on this project, and I'd like to thank him for the images that I'm presenting there. Another project that just had Irish researchers working on it was looking at changes in phenology. Remember that phenocam I showed you a couple of slides back? Looking at changes in the greening up and the browning up of the seasons, the spring and the autumn. Looking at the length of the growing season, the start of the growing season, the end of the growing season, and the peak of the growing season. And these are all critical questions, not just for our natural woodlands, as we can see in the image there, but for agriculture, for knowing which are the right crops, and what should we be advising farmers to grow for changing climates and changing growing season lengths. We were focusing very much on the broad-leaved natural woodlands because we didn't want any of the management principles to interfere with our data. So we wanted to know very much just how the trees were responding to the weather events that were unfolding around them. And so we looked at a range of different woodland areas, different woodland types, different mixes of tree species, and we looked at these at a national scale over the course of many years. We looked at a long time series of Landsat data from 1990 through to 2018 to try and understand more about whether we were seeing an advance or a delay in the start of season and end of season, as we can see in the two maps there. So where we've got the blue points there, we're seeing an advance in the start of season and end of season. Where we're seeing the brown points, we're seeing a delay in the start of season or end of season. And we can see that, yeah, there are some quite clear seasonal trends there, particularly for the end of season. We're seeing a delay in the end of season down in the south and the west of the country by up to 3 days, compared to the more easterly and northerly parts of the country, where the end of the growing season might be occurring earlier by 2018 compared to 1990. So we looked at a spatial scale, a temporal scale, and then we tried to understand something about what might be the different climate drivers of those changes. So we looked at things like the maximum temperature and the minimum temperature and the precipitation. And not surprisingly, we found that the maximum and the minimum temperature were perhaps the biggest drivers of the starter season, or we've got a very high level of correlation and relatively little variability between our different woodland sites. However, something like precipitation was much less clear and much more variability between our different sites. A lot of the work that I do is interdisciplinary. One of the other projects that I've been working on has been looking at wildfires in Ireland. Some of you may remember some of the events, such as the very large wildfire in Killarney National Park in April 2021. And we would be using satellite imagery to be able to automatically identify where these fire events have occurred, and then to be able to map them out in a much higher level of detail than is possible using some of the global international projects, such as the European Fire Information Service portal, which uses data from MODIS and VIIRS, but just presents the fire as a single hotspot, an area of elevated heat. Doesn't tell us anything about where that area burned, or significantly, what is the spatial extent of that burned area. We can see there for the fire in Killarney National Park in April 2021, nearly 1,400 hectares burned. And then being able to take that to the next level and saying not just 1,400 of hectares that burned, but what was it? What different vegetation species burned? And then we can start to ask questions and answer questions about some of the different greenhouse gases and other pollutants that are emitted from the burning vegetation. So just some take-home messages from my career to date, and who knows where my career is going to go over the next few years. In terms of the spatial resolution, well, we can definitely virtually work anywhere and at a wide variety of scales. But I've also been exceptionally fortunate in that I've had the opportunity to physically go to a wide number of different places as well. In terms of the temporal resolution, well, our satellites follow a very regular orbit, but careers don't. And careers can have return journeys at unexpected intervals. I've returned to some of those earlier work on glaciers and cloud cover several times during my career. It's been a recurring theme in some of my different research activities. And then in terms of the spectral resolution, what you're doing is part of a much bigger picture. And sometimes it's easy to lose sight of that and you become very introspective and focused on one small part of your career and lose sight of how that fits into a much bigger whole. And I suppose a few other take-home messages. Perhaps if you're an early career researcher or you've just started in a job and you're not sure really where's all this going to go, how's this going to end up as a career and a successful career for you? Well, don't worry if there isn't a clear plan. Going to university, I had never heard of this subject of remote sensing, but look where I ended up. And, you know, even with choosing whether to do a PhD or go into a commercial company, well, it really just came down to the fact that the PhD deadlines were earlier than the job interview deadlines. So I hedged my bets, applied for a PhD, got offered one, and made the career as a result of that. Always try and be open to new experiences. I was given some very wise advice when I finished my undergraduate degree that if I could travel to different countries, if those opportunities came up, then I should take them. And I'm very grateful for the fact that I did have those opportunities. There was one point in my life where I had the choice between taking a lectureship at a university in London or going to Canada and doing the research that I did there. You can clearly see which I chose, and I have absolutely no regrets about that decision. Sometimes it can be very hard to push yourself beyond your comfort zone, and I'm not just talking necessarily about doing geoinformatics, but one of the first things I had to do when I arrived in Canada was get a gun license before I could go up to the Arctic. That was a huge challenge for me. I'd never held a gun, let alone fired a gun, before I went to Canada. And even still, I'm being pushed beyond my comfort zone. This time last year, somebody suggested to me that perhaps I should apply for the head of school role. I laughed and said, no, that's not for me. Here we are, I'm currently head of school in University College Cork. But I've already mentioned one piece of advice that I was given when I reached the end of my undergraduate career. And I've been the beneficiary of a lot of wise advice from different people over the years. So don't be afraid to ask other people. Don't be afraid to find out more about different people's career trajectories. What were their experiences? And see what you can learn from them. And of course, when the time comes, how can you reciprocate? So unfortunately, I can't take questions in real time. But if you do have questions, if there is anything that you want to ask me about any of the different research projects or any of the different opportunities or experiences that I've had, please don't be afraid to send me an email, f.cawkwell@ucc.ie. It's been current on all the slides, and I understand that the presentations will be available on YouTube afterwards as well. Please do send me an email, ask me a question. I'd love to connect with you and help you. Thank you. Goodbye.
All right, that was very nice presentation from Fiona. As you saw, she provided the email ID for her, like if there are any questions. I'm just also going to copy it one more time. And also, of course, the presentation, this whole recording will be available in YouTube. So I think she also, like Rebecca and Fiona both had a lot of take-home messages or like, which are very useful for early career individuals. So after that, feel free to share the link around after that. So with that, I think, are there any probably any questions, just send it to her. So with that, I'd like to thank Rebecca and Fiona both for their valuable time. With that, I think we're going to end the webinar now. Thank you, Rebecca, also. Yeah.
Thanks. Thank you very much.
Thank you everyone for attending. Thanks.